Hi, I'm Wu, and I'm gonna record a video for question 1 and homework 3 for the course probability and stochastic processes. So the first little question asks us to find B so that probability of x equals to k represents a probability mass function. The probability of x equals to k is defined as right here. So for the first question, if we want the probability of x equals to k represents the mass function, it should satisfy the two conditions. So the first is the probability of x equals to k larger or equal to 0 for all k, and the second condition is the summation of probability of x equals to k equals to 1. So for the first condition, it's very easy to prove. So since the k is defined as 1 or 2 or 1 to the infinity, so it's positive integers. So and p is also defined as is larger than 0 and smaller than 1, so it is also positive. So if b is larger than 0, then the first condition will be satisfied. So and then to prove the second condition, so we can write the summation of probability of x equals to k. We're gonna put this equation into this, so it become b times k times p to the power of k minus 1. So since b is a constant, so we can move the b forward, so it becomes like this. So how to find this part? So we're gonna use the formula. So the summation of p to the power of k is equal to 1 plus p to the power of 2, and it equals to 1 divided by 1 minus p. So if we take the derivative of both sides with p, so it will becomes k minus 1. So and this is exactly the same as this part in the equation. So we're gonna put this into this equation, so it becomes b times 1 divided by 1 minus p squared. So and this left part must be equal to 1, so that the pxk will be represent the mass function. So by solving this equation, we can get that p equals to 1 minus p squared. So that's the answer for the first little question. So and the second question asks us to find the expected value for x. So right here, for this question, the expected value for x, we have a formula for this. It is equal to summation of k times the probability of x equals to k. We can put the equation defined by the question right in, so it will become the summation of b times k squared times k to the power of p to the power of k minus 1. And since b is constant, so we can ignore the b. But how to solve the summation of this part? We're gonna keep looking on the formula right here. So we got since we have already know this formula, so we can also know this formula by just times p both sides. So the right side will become p divided by 1 minus p squared. And then we just derivative the both sides by p. Let me find. You're just differentiating both sides with respect to p, so that we can get I just calculate the result. So it starts from 1 since the first part is being eliminated. So it equals to k squared. So as you can see, this part is the same as this part, so we can substitute this part into this equation, and then we can get this equal to b times 1 plus p divided by 1 minus p to the power of 3. And then we since we already know p equals to this, so we're gonna put b into this equation. So we can get the final answer is equals to 1 plus p divided by 1 minus p. So that's the answer for this little question. So for number C, it asks us to find the expected value for x squared. So we're also gonna use the formula. The expected value of x squared is equals to the summation of k squared times the probability of x equals to k. And since the question defined this for us, we're gonna put this exactly the same as we did in part B. It equals to k to the power of 3 times p to the power of k minus 1. And so how do you solve this part? Since we already know this, so we can, through this we can also know that we just need to times p to both sides to get this equation, p plus p squared divided by 1 minus p to the power 3. And then we differentiating both sides with respect to p. So, and then to save time, I have already calculated this equation. It will look like this: plus p, 4p, plus p squared. So we can substitute this part into this equation, and we can get the here times 1 plus 4p. And then we can get the answer for this, for part C, is right here. So for part D, it asks us to find the expected value of x2 minus expected value of x, but is square. So it's very simple. We just need to use the answer we get from part B and part C to solve this. So it asks us to find out the expected value. So it is equal to, this is the answer we get from part C, minus the answer from part B, but we take it square, so it's right here. And this is the answer for part D. And for part E, it asks us, it's supposed P equals to 1 divided by 3, and it asks us to find the conditional probability mass function for P, the probability of x equals to k under the condition that 2 less than or equal to x less than or equal to 5. So to solve this, since we already know that P equals to 1 divided by 3, so we can also know that P is equal to 1 minus P squared. So it's 2 divided by 3 is square, so it's 4 divided by 9. And then we can write the equation as following. We can change its form. We can change it to the probability of x equals to k and 2 less than x, or less than or equal to x less than or equal to 5 divided by the probability of 2 less than or equal to 5. So we can write we keep this part. We can write this into another form. It's the summation of probability of x equals to k when k starts from 2 to 5. And the above is still the same, and the bottom becomes we just put the value we know into this equation, times k times, so, and then we just calculate this equation again. I'm gonna save time, so we just put my calculated result right here. It equals to 1 divided by 0.538 and times the 4 divided by 9 times k times 1 divided by 3 to the power of k minus 1, for k equals to 2, 3, 4, 5, or 0 otherwise. So that's the question. This is the answer for this question. Thank you for watching.